Good morning and warm welcome to everyone who is watching over this program organized and initiated by Metro PABSON Bharatpur. It's me again, Manish, your science teacher, teaching class 10 science. And the topic acid base in salt, the subtopic indicator. Today most probably it would be our last day to complete this topic. So let us begin. Indicator. The name, the title itself is quite clear. Indicator means something that indicates. Here in acid, base and salt, indicator means those chemical substances which help you to identify whether the given chemicals are acidic in nature or basic or neutral in nature. These indicators identifies the given chemical substances by changing the color of themselves. Acid, base and salts, when treated with different types of indicator, they bring change in their color, and we must know what sort of changes means which acid or what kind of chemical substances. Then we can come to conclude the given chemical, what are they. See, I have written here two types of indicator. Number one, ordinary indicator means simple indicator, and the second one is universal indicator. Ordinary indicator are of following types. You can see here: litmus paper, methyl orange and phenolphthalein. But nowadays we can use red cabbage juice also as a ordinary indicator. But these are most commonly used indicators in science lab. This litmus paper also can be found in two color. One is red litmus paper and another one is blue litmus paper. Now let me just say what happens when acid, base and salts are respectively treated with different types of ordinary indicators. Just have a proper look here. Let me take one example of acid, HCl. This is an acid. Whenever acid is treated with red litmus paper or blue litmus paper, see the change here. HCl is one of the strongest acid, I said you already. See here, whenever hydrochloric acid is treated with red litmus paper, there comes no change. No change in color means no effect, no change. But when acid is treated with blue litmus paper, blue color gets changed into red one, means it turns to red color. This idea you must know in order to find out the given chemicals. You must know at least what sort of changes acid brings with indicator. You must know that at least. Similarly, when acid is treated with methyl orange, methyl orange is found in a liquid bottle. That liquid, some drops of liquid and some drops of acid when mixed together in a test tube, you can find methyl orange being changed into red color again as similar to blue litmus paper. Originally methyl orange is somehow orange color or light yellow color substance, but when it is dipped with acid solution, it turns to dark red. So this idea you must know at least with blue litmus paper. If some chemical bring change in color making it red, then it must be acid, and to confirm it you can use another indicator, methyl orange If it is also changed into red color, then confirm the given chemical is acid. Otherwise, you may go to another testing. See what happens with base. This is an acid, I said. Now base, let us take one of the base, NaOH, sodium hydroxide, one of the strongest base. See the changes it brings with these indicators. With red litmus paper, base shows some change in color, means red litmus paper is turned into blue color when treated with base. With the same indicator, there was no change brought by HCl, but base brings some changes. So, this contrasting nature of acid and base is what we are able to find them in chemical lab. See here, blue litmus paper, base does not bring any change in color. With blue litmus paper, we can write here no change in color. But with methyl orange, does it bring any change? Let us see. Methyl orange, I said originally it is somehow orange color substance, but when it is treated with base, its color somehow changes to typical yellow color. Maybe that may vary from light yellow to dark yellow, but typical yellow color it becomes. So, this also helps you to find out the base, light yellow. So, I have not written anything about phenolphthalein. Let me talk about that also. Phenolphthalein, let me write here, no problem. Phenolphthalein, see, acid does not bring any change with phenolphthalein, no change. Let me say you one thing, phenolphthalein is originally colorless liquid substance. With base, phenolphthalein brings some change, interesting change. Phenolphthalein is converted into pink color liquid when treated with base, pink color. Look, actually there is no repetition in the nature shown by these two chemicals. If there was some kind of repetition or overlapping or some same changes, then it would be a problematic one, because acid also changes the given litmus paper into the same color and base also does the same. That would be difficult. In that way, we would never separate given chemical substance, but because they bring different kinds of changes with themselves, it is easier for us to identify the given chemicals. But I said you must know at least which chemical bring what kind of changes, then only you can identify the given unknown chemical. So, this is the change. You just one more time remind it. There comes no change in color with red litmus paper when you treat it with acid, but acid changes blue and methyl orange, blue litmus paper and methyl orange into red color. But base shows changes with almost 3 different indicators, but base does not change blue litmus paper into any other color. Otherwise, base changes red litmus paper into blue, methyl orange into light yellow color and phenolphthalein into pink color. This property of base help us to find out the given chemicals. Okay. Now, let me just rub it. Okay. See here, we talked about litmus paper and the changes we can find out when these indicators are treated with acid and base. But what happens when these chemicals are when these indicators are treated with salt. Actually, I said you already, salts are mostly neutral chemical substance. Neutral means what? Neutral means they do not bring any chemical change with any indicators. So, you take red litmus paper or blue litmus paper or methyl orange or phenolphthalein, no matters, but salt shows neutral nature with them. Salt does not bring any change in color with them, but keep in mind that salt must be completely neutral in nature. Some salts are there acidic, some salts are there basic in nature, some salts are acid salt, some salts are base salt. These types of salt somehow bring change in indicator. If you find given chemical or given salt, you know at least the given chemical is salt, but you do not know whether it is neutral or acidic or basic, say, then you can at least come to find out the given salt is acidic or basic in a way we did just now. Means when given salt is treated with red litmus paper, if it changes it into blue color, then you must consider the given salt is basic salt. If you find out the salt bringing a change like methyl orange is converted into red color, then you must conclude the given salt is acidic salt, because the property is quite similar to acid. Fine. So, you must consider if it is neutral, then no change with any other indicators found, but if it is acidic, similar changes what acid brought is observed, and if it is basic in nature, then similar changes what base brought is observed. Fine. So, let me say you something about this red cabbage juice. This is also one of the ordinary indicator. This indicator also brings changes when it is treated with acid, base and salt, and the changes would be quite similar what acid does with other indicator. Means red cabbage juice also get converted into red color. Likewise with other two. So, what's next? See, another type of indicator, universal indicator. Before I move completely to universal indicator, let me first mention what materials as a raw materials we use to prepare ordinary indicator. Ordinary indicators are, let's say, fully organic. I mean to say, ordinary indicators are made from different parts of plants. The plants may be root, stem and leaves, maybe buds, parts of flower. Look, when these parts of particular plants are collected, crossed, refined and chemically processed, we get ordinary indicator. So, I said ordinary indicators are fully organic, means they are prepared from different parts of plants after they are chemically processed. But what is universal indicator and what materials are used to make universal indicator? Let me share that too. Universal indicator are more refined form of ordinary indicator. Whenever ordinary indicator are mixed together and chemically processed, in a way it is upgraded, it becomes universal indicator. Then why do we need universal indicator if it requires complex mechanism to make it? If ordinary indicators are already there to identify the given chemicals, then why do we need universal indicator? Let me inform you. Ordinary indicators are why they are said ordinary, why they are said symbol. It is because they just help you to identify the given chemicals. They just help you to identify the given chemical is acid, base or salt, but they won't ever say you the given chemical is that much strong. The given next chemical is somehow weak. It is bad conductor of electricity and it is poor conductor of electricity. You cannot find out this information by using ordinary indicators. They only tell you what the given chemical is and what their nature is, but not the strength. So, you have to come to universal indicator if you wish to find out their strength as well. Means how strong the given chemical is. If it is acid, after you identify the given acid, how strong it is and how weak it is. Is it organic or is it non? Is it mineral acid? If so, then how strong mineral acid is it? You have to come to universal indicator. And you can see here universal indicator, there are different instruments, different things that deals with universal indicator: pH scale, pH meter and pH paper. What does pH means? What does pH mean? pH means simple potentiality of hydrogen ion in the given solution. Potentiality of hydrogen means how much hydrogen does that solution contains. On that basis universal indicator works. So, see, here you first come with pH paper. Here I have shown something to you. pH paper means it looks somehow like ordinary litmus paper, but with no that type of color being red and blue. It is somehow skin colored paper, and when that paper is dipped into the given unknown chemical solution, then it shows some change in its color, and that change should be tallied with pH scale. Here is pH scale. The change brought upon on the pH paper is tallied with pH scale. pH scale somehow looks like this. See, pH scale, in pH scale marking is done from mainly 1 to 14 with 7 in the middle part of it. If you find the color brought upon by pH paper similar to the color kept here in 7, that is green color, then you must consider the given substance is neutral in nature and pH value 7. If you find pH paper being converted into dark red color, then you have to tally their color with the different color organized here in this scale. If you find that color being similar to the color kept here, then you must say acid. This is acid with pH very close to 1, means very strong. So, what does this pH scale indicate? pH scale indicates that if some things come with 7 value, then it is neutral in nature, and if you get pH less than 7, then you must consider the substance is acid, and if you go above the 7 towards the 14, means when pH is increasing, you must consider alkalinity is gradually increasing. So, substance with pH 7 represent neutral substance, and substance with pH less than 7 indicates the given substance is acid. The more lesser value you find, the more strong is it. Means strength of acid, strength of strong acid is determined by low pH value, whereas strength of strong base is determined by high pH value. So, we may say acid with pH, see here, acid with pH less than 2 is strong acid. Look, some chemicals with pH less than 2 is strong acid, but if given chemicals have pH more than 2 means 3, 4 or 5 or 6, then they are acid, but they are weak acid. Mostly organic acids that are edible have pH more than 4. The acid you regularly eat in your kitchen, let me talk about citric acid you get in that lemon that has pH value more than 4. That is weak in nature, but somehow strongly sour, but it does not corrode your skin. It can be eaten. Anyway, it is weak, but so it has pH value more than 4, less than 7. What about base? See, I said if something has pH value slightly greater than 7, you must consider it is somehow basic in nature and it shows alkali property. If you find base having pH value 13 or more than 13 or say more than 12, then these chemicals are strongly basic in nature. So, this pH scale when tallied with pH paper, you may say pH paper when tallied with pH scale, you can well conclude how much strong the given chemical is. So, this is universal in nature in that sense. There is another way you can find out directly the digital value of pH, means you do not need to first put paper in that chemical and tallying that paper with pH scale. Here pH meter is advanced form of universal indicator. The chemical you want to identify along with its strength is to be some drop of that chemical is to be put in that pH meter, then pH meter works process and shows you the direct digital value. So, pH meter have been in use much nowadays to identify the given chemicals along with their strength. So, this is all about universal indicator, and I said you already universal indicator is better than ordinary indicator in that sense in which it identifies the strength too. So, it is made up of different ordinary indicator after they are mixed and chemically processed. Okay, this is the end of today's class, and I must say we completed the topic acid, base and salt. If there is left some unknown part regarding this salt, you may consult with me. I have already provided you my email ID and other identities of mine.